Hello, and today we'll be talking about factoring a difference of two squares. My name is Pirate Labradorf, and I will show you what we must do. I will get rid of this accent because it is ridiculous. Arr! So, welcome guys. Hopefully you're enjoying your break, and today we are going to be talking about factoring a difference of two squares. Last week we talked about factoring GCFs, which we might see in this case, and we also talked about factoring trinomials. But in this case, we're going to talk about one of our special products, and that is a difference of two squares. Well, what is a difference of two squares? It's when we have one square, a squared, minus a second square, b squared. You have a perfect square minus a second perfect square. When we have that, what we end up getting is two binomials, or two groups. Whatever you square first here goes first in each case. And whatever you square second goes second in this case. Both of these groups have an A and a B. Now, what do we put between them? One of them's a plus, one of them's a minus. So let's go ahead and take a look at this. So I see r squared minus 9. First off, I always suggest identifying what you're squaring. So what are we squaring to get r squared? We're simply squaring r. So I'm just going to put that in a little group for a moment. R squared minus, what are you squaring to get 9? You're squaring 3. This is not truly factoring, but what it is doing is that it is identifying what you're actually squaring, or what your A and your B is. So now let's make our two binomial groups. What goes first is this r, not r squared, but r. What goes second is this 3. And the only thing left we have to do is put a plus and a minus. Now, it truly doesn't matter if you have a minus and then a plus, or a plus and a minus, because we're really multiplying two things, and it doesn't matter what order we multiply in. So we have an r plus 3 times an r minus 3. We could have also written r minus 3 times r plus 3. Let's take a look at some others. So, again, we have a perfect square here minus a perfect square here. We're squaring 4 and an x to get 16x squared. Minus, we're squaring 5. So the two things we want to look at is this 4x and this 5. So now let's make our two groups. What comes first in both of them? 4x and 4x. What comes second? A 5 and a 5. And we put plus and a minus. That's not bad. Again, we're looking at this pattern. Let's take a look at this next one here. We have not one variable, but two. Don't let that throw you off. We still want to identify what we're squaring to get that first term. And to get 9u squared, you have to square 3 and u. Minus, what are you squaring to get 4v squared? You're squaring a 2 and a v. So, again, what's on the insides of those really ends up on the inside of these two binomials. We put 3u first in both cases, and we put 2v second in both these cases, and then put a plus and a minus. Again, it doesn't matter the order of the plus or minus. This one over here is just another example. But what happens if the variable comes second in these cases down here? Let's take a look. Does it change what we're doing? It doesn't. What do you square to get 1? You square 1 to get 1. What do you square to get m squared? You square an m. So we make our two groups. What goes first in each one of these groups? This one does. The variable doesn't come first in this case. It's whatever you square here in this first case goes first in each one of these. And then since we're squaring the m, that comes second. And then we put a plus and a minus here. One more like this. Again, you're squaring a 5 to get 25, and you're squaring an n to get n squared. So, our two groups, you put the 5 first, and the n second, and then plus and minus. That's not too bad. What about these last two down here? Well, when I look at it, I want to square 2n squared, but if I square 2, I don't get 2, I get 4. So I do not have a perfect square here. Matter of fact, both of these are not perfect squares.
But remember what I said at the beginning? We might have a greatest common factor. So let's see if we can take out a greatest common factor. What divides into 2n squared? That also divides into 8. And you're right, it is a 2. So let's take out the 2 first. And you're left with n squared minus 4. Take your 2, put it all the way down at the end so you don't forget it. So we really want to focus now on n squared minus 4. Is n squared a perfect square? It is. We will square the n to get n squared, and we will square 2 to get 4. So this difference of 2 squares here factors into, and I'm just going to put it next to the 2, n comes first in both cases. This 2 comes second in both these cases, and I write a plus and a minus. Let's do one more. I've been doing a lot of green. How about a blue? Is 18n squared a perfect square? It is not. Neither is 32. But is there a perfect square that divides? Is there a number that divides into both those? Yes. 2 does. So I'm going to factor out a 2. So 2 times what gives you 18n squared? 9n squared minus. Does 2 divide into 32? It does. 16. I'm going to take my GCF, put it all the way down at the end, and focus on the 9n squared minus 16. Is 9n squared a perfect square? It is. You have to square 3n to get 9n squared. And is 16 a perfect square? It is. You have to square 4. So, one perfect square, second perfect square. Let's make our 2 groups. Finish this off, and we have 2 on the outside. 3n comes first in both of these cases. The 4 comes second in both these cases, and then I write a plus and a minus. And those are our difference of 2 squares. The one thing I wanted to point out, in every single one of these difference of 2 squares, you notice the word difference. That means subtraction. You notice you have a subtraction. If you did not have a subtraction, then this is not a difference of 2 squares. So keep your eye out for some questions that don't have a minus. If it doesn't have a minus, then you cannot factor it like this. Only when there's a difference between those 2 perfect squares.
Hopefully you've enjoyed yourself this little fun time, and you'll be able to use it to handle your homework. So get on out there and try some factoring. Ha ha!